So now, in this video, we have a Trimpot that is parallel, the two ends of the Trimpot, to a Zener diode right there. And then we have a 1000 ohm resistor that is in series with the two of them, because they're in parallel, to the positive supply right there. So what we have is a Zener voltage, because current can flow through that way as long as we have a high enough supply voltage right there. And also a Trimpot, so that we can get a fraction of that Zener voltage out. That is the main goal of this circuit fragment right here. So for whatever reason, I don't want a percentage of the supply voltage. So if I set this halfway, we got 7 volts. That would mean 3.5 volts. If I have this set halfway still, we go to 15 volts, then that would be at the output 7.5 volts out. So as the supply voltage changes, the signal voltage would also change. When we have the Zener diode parallel to it, that maintains 5.6 volts approximately across the Trimpot right there. So I set it halfway, we'll have about 2.8 volts regardless of the supply voltage, as long as we don't go so high that we damage something or so low that we lose the Zener voltage. The voltage goes down below the Zener voltage, then we would get a fraction. Hopefully that makes sense. So in any case, we got that. Of course, when you use a Zener diode, you use it reverse bias. You put it forward bias, it'll probably pass current at about 0.7 volts. And so you use it reverse bias. That's the direction it does not conduct well, but that's its Zener voltage. They're specially made to conduct well reverse bias. Most diodes, you do not just wire to conduct reverse bias. You got to make sure it is made to do so. So yeah, we will look at that with the multimeter right there. Pretty simple. We're just going to measure voltage. So all I got to do is set the meter to V there. It's auto ranging. It does the rest. Red probe, I don't have to move it for anything other than high current. And we're not going to measure high current in this video. So we will take the probes here, and I have alligator clips. I do this a lot, so I'll kind of rush through this. Our voltage we're interested in is in relationship to ground, of course. So I kind of assume you're already familiar with Trimpots and with Zener diodes. We're just connecting them together. That's it. So I'll try not to stretch this out too long. But in any case, yeah, power supply is on. So I am wondering why we got 0 volts out. That's all the way to the positive supply. So now I figured out why we couldn't get a measurement. So there you can see we got the ground jumper. We got where the reading will be, which is right above it. But there you can see that's where the Zener diode, right above where this jumper is where the Zener diode and the resistor are supposed to be right there. So I'm going to lift this up. And unfortunately, the board's kind of catching this, so I'm going to have to do some modifying of the leads. And I might have to actually do that before I can insert this. So now I used my pliers to help straighten the lead a little bit right there. And so yeah, I want to go up 2 above where that ground one is, and then move the 1K resistor down 1 spot, making sure I stay to the power supply. There, now we will get our Trimpot voltage. So I'm going to leave that in there because miswiring is one of the easiest ways you make a mistake. And I forgot, I disconnected that alligator clip there. So we want to get a reading. So in any case, there we go. We got 3.4 volts. And of course we can go up to 5 volts. 5.6 volts because it's a 5.6 volt Zener diode. We're working with 7. Oh, I guess we're working with 9 volts. That's right. I kind of changed it when I was trying to find out what was going on. But in any case, we will set it to about halfway of 5.6 volts. So 2.5 would be half of 5 plus 0.3. So that would be 2.8 volts. Should be halfway. And we don't have to be spot on halfway. You know, there we go. 2.7. Close enough right there. Main takeaway is we got that voltage, 9 volts. We can go down to 7. It will likely change just a speck because the Zener voltage is not perfect. It varies a little bit based on how much current is flowing by it, but it's fairly solid with the 5.6 volt Zener down. There you can see we're still 2.7 over this wide range of supply voltage right there. So if we want to be able to adjust a voltage that's going to remain steady, as long as it's not too close to the supply voltage, we can set a maximum with the Zener voltage. This is one way that we can do that. So, you know, pretty straightforward. And I had that blooper and stuff, so this video is going to be longer than I expected. But you know, that's the way it is. The miswiring is very common. Reason why your circuits don't work. So if your circuits don't work, closely look at every connection. Make sure they're in the right spot that you know, you need to make them. So again, I accidentally put the Zener diode, instead of 2 spots up from ground there, 3 spots up. Same with that 1K resistor. They weren't touching the Trimpot at all. So we were getting through the resistance a connection to ground, but it's still a connection to ground when nothing is to the positive supply right there. It just provides some resistance, but the multimeter has, you know, tons more resistance. It doesn't even see this resistance that we provided when you're just measuring between the wiper and to ground when you're measuring a voltage. It's not a voltage divider anymore. It's just a pull down resistor to ground until we moved this to the high side. Then it became the voltage divider. Hopefully that makes sense. But in any case, that's it. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen and check out links down below. They all help out a lot. I'll see you in the next video.